Hello friends, this is Durga again from IT University. As part of this and a few more videos, uh, I will be covering about file operations, how they work in the context of Oracle database. Before getting into the details about file operations, let's see little bit in detail uh, the architecture of Oracle. Okay, I'm putting it in the slideshow. So when it comes to Oracle, these days typically it is RAC, which is a clustered database where you will have multiple database servers, and the storage is separated from the database servers. The reason is before Oracle ASM and other things came into picture, Oracle used to have means Oracle databases used to work with CPUs, memory, and the storage, which are closely located within the server itself. So you have the hard disks on the same server along with the CPU and memory. But the disadvantage of that is if a hard disk fails, then there is outage for the database. To avoid that, they have decoupled the storage from the CPU and memory and stored it on a separate rack which is connected through network with the database servers. And they have the capability of transparent disk failures because of the concepts like RAID and other things which will take care of striping and mirroring of the data that is being stored in this storage which is hosted on the separate storage cluster. So this is to visualize the storage cluster, and the bigger gray box is storage rack itself, and the horizontal blue rectangles are to depict the hard disks. So you can have as many hard disks as possible in the rack that can fit into it, and then you can carve out the storage into multiple pools, and that pool will be mounted to the database servers over the network. So you will have a network switch that will be connected to the storage server, and then database servers will be connected along with storage cluster on using this network switch, and this vertical green rectangle will be mounted on all the database servers on which our tables and others will be created, and we will get into those details in a moment. Okay, so this is the high level architecture about Oracle. As part of this video and next few videos, I will be primarily focusing on this vertical green rectangle, and we will see how the storage is used to store the data of a table. Okay, now I will try to whiteboard new. So in this, actually I will try to cover some important concepts so that you understand how the data is being stored in the database. They are tables, table spaces, data files, segments, and extents. We will try to understand the relationship between each of them. So when we actually create the user, the thing is, let's say we have created the user called P tuning, right, as part of one of the earlier videos of performance tuning. If you don't, you can actually go back to the script, and there is a simple create user command which you can use. But if you are not DBA, it is not that much relevant anyway. So there is a view called select star from DBA underscore users, and you can actually pass the username also equal to P tuning, and you can run this query, and it will give all the details at the user level. It will not show you the password directly here, and it will say whether the account is open or not. And then one of the important aspect is default table space. So any table that is created using simple create table command like this will be actually go to the default table space unless you specify the table space clause here. So here we didn't specify the table space, but if you go to the DB underscore users, the default table space is users. So the deck of cards table will be under default table space You can check that by running this query, because we have already created the table. This is the owner, this is the table name, and this is the table space. So this is the relationship between the table user and the table space. So a table space can be assigned to multiple users also as a default, and also you can give permissions on a given table space to multiple users also. So it's a many-to-many relationship between a user and the table spaces. But a table space can have many tables, but one table is always associated with one table space as long as it's a non-partition table. If it is a partition table, it can get into multiple tables also. So for a non-partition table, it's a one-to-many relationship between table space and tables. A table space can have many tables in that. So what is this table space? Table space is nothing but a logical structure. You don't find anything if you try to search physically about the table space. But if you run this query on db underscore table spaces and also db underscore data files, it will give you some other insights, what all database files that are associated with this table space. So table spaces will have information at table space level. It has how the extents needs to be associated with the table space, or all the tables that will be part of this table space. Don't worry about it. We will get into the details of extent in a moment. But at this time, if you want to see what is actually physically used for the table spaces, so that it can actually store the tables, you have to run this query against db underscore data files, where table space name equal to whatever table space you want to check in. So you can run this query, and you can see that there is a file called which ends with .dbf on the file system. You can actually log into the server and check this location, and you will see this file. So it is called as database file, and then it shows the table space name also associated with it, and then it has the properties of the database file. Okay, so this is the physical location for this table. So for this table space. So a table space can have multiple tables, and a table space also can have multiple database files, not one just database files. Now let me start drawing the picture. Okay, so you have the table space, which is users in this case, and you have the file system, which I have shown as when I explained the architecture, that green vertical box. And there can be many database files. Let's name them as db1, dbf1, dbf2, and dbf3. So there can be the case that more than one database file can be associated with a table space, but only one table space can be associated only with one table space. In this case, dbf1 and dbf2 can be associated only with users. They cannot be associated with a different table space, and so there can be another table space for these two things, dbf4, and it could be called as tbs1, table space 1. So now let's say that let us primarily focus on users. It can have more than one database file, and users can have many tables also. It can have table 1, table 2, and our deck of cards. Okay, and all the data related to T1, T2, and deck of cards. Let's say T1 is red, T2 is green, and deck of cards is some other dark color. Okay, so we will use this color for deck of cards, this color for T2, and this color for T1. Now let us see something called db underscore extents. What is there with respect to deck of cards when it comes to two more important views, db underscore segments and db underscore extents. So first let us run this db underscore segments. So when you run this query, it will just have the segment name. For a non-partition table, the segment name will be same as table name, which means that there is a one-to-one mapping between a segment name and a non-partition table. So one non-partition table can have only one segment associated with it. And now we will see little bit more information. There is something called blocks, which is 8, and there is something called initial extent, which is 65,536. What is this 8 and what is this 65,536? So 65,536 is nothing but bytes, okay, and block means there are 8 blocks associated with this table. And what is the size of the block size? You have to go to the DBA tablespaces, run this query, and you can see the block size is 8 KB. So this 8 KB into 8 blocks under segments is nothing but 65,536 bytes, which is nothing but 64 KB size. So the segment size as of now is 64 KB, or if it is represented in blocks, it is 8 blocks, and there is only one extent related to it. So if you run this query, db extents on this table, you can see only one entry in that, and the blocks are 8 blocks for that extent, and the size of that extent is 64 KB. Now let us go back to the whiteboard and let us see what happened in this case. So deck of cards have 8 blocks. So I am using the green here. It could go on to any file. In this case, let's say it has gone to this dbf1, 5, 6, 7 and 8. So there are 8 blocks, and all these 8 blocks will be contiguous. So whatever is mentioned in the extent, for each extent, and there will be those many blocks that are defined in the block section for the extent. So so this one is considered to be one extent, let's say E1, and it will have the data whatever we insert. Even though the table is empty or it can fit many records, still the allocation to the table will be based upon the attributes that are applied when we actually create the table space. When we create the table space, if you go to the properties, it will have what is the initial extent, what is the next extent, and all those things. Those all things will be applied on the tables by default unless you override while creating the tables. Anyway, that is not that important at this time. Just understand how the data is stored physically on the database files. So physically it will be stored as blocks, and those contiguous blocks are called as extents, and a group of extents which can be across many database files for a given table space is called a segment, and that segment will be associated with one non-partition table if the table is non-partitioned, and that's how the data will be stored. And there is a relative byte address for each and every record on each and every block for a given table, and that relative byte address is nothing but RowID. Using RowID, Oracle can understand on which file and on which extent, and in that extent in which block, and in that block what is the relative location of each and every record that is there in the table. That's how when we actually run the query, it will go through the files and extents and blocks to retrieve the data you need. So that's how data is stored in the physically stored in the database. Now let us insert more data into this table called deck of cards, and let us understand the behavior. Okay, so now I am running this insert into query. Okay, before running into that, running that query, let me run the select star from db extents again for this segment or table deck of cards. There is only one extent in the table, and it has 52 records. Now I am running it again. Let me run all the 4 queries, which will give the count also. I am trying to select the same table and reinsert into the table. I ran the query again. Now you have 104 records, but still there is only one segment. I am running it again, and now you have 208 records, but still there is only one extent. So let me close all these query results. Now I am running it again. Now you have 416 records, but still there is only one extent. I am running again. Now 832 records, but still there is only one extent. Now 1664 records, but still there is only one extent. Now 3328 records, but now there are two extents. Okay, so what happened? There is another so there are 8 more blocks created. Again, we need to see the blocks size, blocks and the size of that extent. That extent is still 64 KB, and it has 8 blocks. And this block ID is the starting block ID of those 8 blocks. So starting from 624 through 631, the new 8 blocks are associated on this file. Again, the file ID is same. So in this case, you can visualize in such a way that it has created 8 more blocks for the table, which is extent 2. Okay, and it can, so if you have multiple database files for a given table space, this extent might go to the second database file also, but in our case there is only one. That's why the file ID is same for both the records. If there are multiple database files, there is a good probability that data might scattered under multiple database files also. And now let us run this insert into command few more times. Now let us see. Now let us see the DB extents. You can see that it has 50 extents. Okay, but if you see up to extent ID 15, which is 16th row, the block size, the number of blocks are 8 and bytes is 64 KB, because 8 into 8 KB, which is the block size when we for this table space, it is 64 KB extent, which means 8 contiguous blocks up to this one. But if you see this is 128 KB. Sorry, 128 blocks, and this is 1 MB, not 64 KB anymore. So why this changed suddenly? Why it has grown by 64 KB every time until it reaches the 16th block, and then why it went up to 1 MB? That's where the initial extent and next extent comes into picture when you query these data dictionary tables like db underscore segments, db underscore tables, etc. So here you can see that initial extent is 64 KB and the next extent is 1 MB, and the minimum extent is 1. So it will start with one extent which is of size 64 KB. Once it reaches this 64 KB, once the data is populated in this 64 KB, this next extent comes into picture, and there will be 1 MB extents from next time. But I think I'm not 100% sure here. I think based upon the value of the next extent, if your initial extent is smaller than the next extent, until it reaches the size of the next extent, only then it will be this next extent property will be applied. Again, I am not 100% sure on that, but seeing the behavior of the data, that's what I speculated. I might be wrong. You can go deep and try to explore further. And now if you recollect the DB extents query earlier, it was only one extent when we start. Now it's 50 extents. Even the bytes is changed. So whatever is happening under the covers on the table, our segment view is getting updated. So segments view actually have the most recent information about size of your table. So if you want to understand the size of the table and all, you can use the DBA segments directly, and you can apply some of bytes by 1024 by 1024 if you want to see in the megabytes. In this case, the table size is already 36 MB. So you can run this query bytes 1024 1024, and you can see that it is 36 MB table. For some reason it is taking a while. Connection is getting disconnected very frequently with Oracle Cloud, probably because of internet connectivity issues as well, but it is 36 MB for sure. Actually, we can go to here, sudo su Oracle SQL plus p-tuning, enter the password, and you can actually run this query. Yeah, so the connection is closed. Let me reconnect. Okay, now the connection is reconnected. Anyway, we can run here also. You can see that it's 35 MB. Now let me insert the data again. We have 50 extents, out of which 16 are 64 KB, and other 34 are 1 MB extents. And now commit it, and now run this query on the DBA segments. Now we have 72 extents, and you can also run this query on DBA extents, and you will see approximately 80 extents, out of which first 16 are only 64 KB, and after that it's 1 MB, and now it actually reached 8 MB. I think internally it uses a concept called ASSM, automatic storage management concept, and depending upon the size of the table, the next extent might adjust. Now let me review certain things again here. I am going back to select star from DBA segments and see what is the next extent value is. Next extent is still 1 megabyte. So somewhere I think internally it is trying to manage itself so that the storage is used effectively. Why it has to manage itself? The reason is if your segments are scattered, where is it? If your segments are scattered, then it has to do too much of I/O. If the and also it has to seek where your blocks are. But if the blocks are scattered, not the segments, if the blocks are scattered, every time it needs to perform the I/O, it has to seek where the blocks are. And by having larger extents as the table grows, it need not seek on the entire database file to figure out where your blocks are. It will just do the sequential read when it try to read the data on larger extents without spending too much time on seeking where these extents or blocks scattered on the database file. That's why instead of tables scattered, instead of data in the table scattered in the form of blocks across the database file, they introduced the concept of extents. Extents is nothing but contiguous blocks that are used to store the data for a given segment, and segment is the one which is mapped with the table associated with it, and which will actually manage how the data is stored on the database files. So this is the starting point to understand how the data is stored, and we have covered only a heap table, which is a typical table and a non-partition table. As part of the subsequent videos, we will see how a partition table will be managed, how what are the others, how an index will be managed. All these things have to store the data, and that requires that knowledge requires in many aspects, like performance tuning. When we actually talk about performance tuning, you need to understand all these things, like what is a table access full, what is the table access by index RowID, what is index range scan. All those things you need if you want to understand those operations when you visit the explain plan. Then you need to understand how the data is stored in the database in the form of segments on database files with extents and blocks at the bottom. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you have any comments or if you have any technical questions, please use the comment section of the video. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.